All right. Hey, everyone. Welcome back. Uh, so today we're actually going to be starting on uh, balancing equations, like writing and balancing equations. Okay. Um, so your notes, the unit 4, the nature of chemical reaction notes, will be posted. There's just some general information here that we're going to cover, and then we'll get into like the balancing. Um, so chemical reactions is a process in which one or more substances are changed into new substances with different physical and chemical properties. So we've already kind of talked about um, physical versus chemical changes, chemical reactions, or chemical changes. Okay. The term reactants or reagents, they mean essentially the same thing. These are either a substance or substances that enter into the chemical reaction. So it's the stuff that you have before the reaction occurs. Okay. And then you have products. These are the substance or substances that result from the chemical reaction. So this is what you get or what is there after the reaction is completed. So those are the products. Uh, in general, for a reaction, the more stable the substance, the less reactive it is. Also, the reverse is true. So take something like glass, for example. The reason we use glass to hold so many different substances is because glass is extremely stable and non-reactive. Okay, um, glass does not react with much at all because it's so stable. All right, and then the reverse of that is also true. You take something like, say, typically your acids, hydrochloric acid or sulfuric acid. They're very reactive. They're very reactive because as a compound, they're not really very stable. So they react with a lot of things because through the reaction, they actually become more stable. Okay. Um, the 4 signs of a chemical reactions we've already talked about in previous units. Just kind of here as a reminder, that's why I don't really explain them. Formation of a precipitate, production of a gas, changes in temperature, and changes in color. Okay, and keeping in mind that with these signs of the chemical reaction, we're talking about things that occur when you put two substances together, not when you actually manipulate the variable. So, like if you boil water, you're changing the temperature by adding heat. This would be something where, like a hot hands, heating pack, where you open it and then when it mixes with the air, it just starts reacting. Like you're not actually adding or taking away heat from it, like that kind of stuff. Okay. All right. I'm actually going to skip around. Um, so this is sort of like writing chemical equations, which is actually I will come back to tomorrow in your lecture for tomorrow. Um, I'm going to go to the balancing chemical equations because today's homework is just going to have you balancing, not writing any of the equations. Right. So, and I believe you guys have done balancing equations before, at least somewhat. So hopefully this is uh, just a little bit of a reminder, knocking some rust off. But I will go through it completely just in case you've forgotten or for some reason you haven't had it before. So we have the law of conservation of matter. The law of conservation of matter says that in any chemical reaction, matter is neither created nor destroyed. It is only, converted or changed forms. So what this tells us is that everything we have on the reactant side of the equation must be there on the product side. You can't lose any mass, you can't lose any atoms, you can't gain any atoms from nowhere. Okay, so what we're saying is this is the chemistry version of an equation, right, of a math equation, where everything on the left side of the equation must equal everything on the right side. Okay, so and then a helpful hint for balancing: balance elements in order of how many substances they are found in within the reaction, from fewest to most. Okay, you're balancing the individual atoms, the number of atoms for each element. All right, so we're going to do some examples here. We've got oxygen plus hydrogen creating water. Okay, we're going to create a T-chart. So the way that we do a T-chart is you write the element down. Okay, so I'm going to write down oxygen, and you write all of your elements down, and hydrogen. Okay, now I'm going to create a T-chart. So let's do this. The line down here where the arrow is like the equal sign. Okay, so the number of atoms of reactants have to equal the number of atoms of the products. So we start counting how many we have. So on okay, so this side of the reaction, the left side is the reactants, and the right side is the products. All right, so I'm going to go over here. Remember, these subscript numbers tell us how many atoms of that element there are. Okay, so over here, 2 oxygen. Put a 2, my oxygen. And I've got 2 hydrogen. Put a 2 for the hydrogen. Okay, on the right side, on my product side, okay, I've got 2 hydrogen. And I've got, there's nothing down here, so there's nothing there, it's just 1. So 1 oxygen. Okay, so that would be my T-chart. That would be what I start with. All right, then what I'm going to do, and you can do this in any way you choose. I usually, a lot of times when I'm doing them, I'll start it off in pen and then I'll do pencil. So that way, if I do something wrong, I can erase and go back, but I have like my starting numbers or whatever. You can do it all in pencil, that's fine, whatever. But so what we are doing is we are adding coefficients. Coefficients are the numbers, just like in math, in front of the compounds or the elements, substances. Okay. So once you have this, like you don't put any subscripts or change any subscripts numbers down here. The only thing you do to balance is you add numbers in front of the substances until it balances. Okay. Now, the coefficient, whatever number you put in front, is multiplied times the subscript to find out how many of that you have. So, for example, if we look here, these numbers have to balance in our T-chart. So we've got 2 oxygen, 1 oxygen on the product side, 2 on the reactant, 1 on the product. So I need 2 oxygens over here. Okay, now a lot of people sometimes they mess this up and they'll think like, well, if I just add 1, then I've already got 1. So no, it's not what you're doing. Okay, the number in front is multiplied. So if we've got a 1 on the oxygen down here, we need to put a 2 here. Okay, that's 2 times 1 will now change our number of atoms of oxygen on the product side to 2. Okay, now because this is in front, so whenever you put this in front of a compound, it affects every element in that compound. The coefficient does. It goes to everything. So we have 2 oxygen now. We also have 2 times 2, or 4 hydrogen on the product side. Okay, so if we look, our oxygen are now balanced, 2 and 2, but our hydrogen are no longer balanced. They were, but they're not anymore. We've got 2 on the reactant side and 4 on the product side. So I need to get 2 more over here. Right? How do we do that? Well, I need 4 total, right? So what coefficient can I put in front of here to give me 4? Remember, we're multiplying. Okay, so if I put a 2 in front of this, 2 times 2 gives me 4, and that changes the hydrogens, and my oxygens haven't changed. Okay, now if I look, 2 oxygen, 4 hydrogen, boom, I'm balanced. So this is the balanced equation. Okay. All right, let's try a second example. So I've got this. I'm going to create my t-chart. Okay, so I'm going to do this, and I'm going to put my line where my arrow is. Okay. All right, I'm going to split these all up. So I'm going to do manganese, oxygen, hydrogen, chlorine. Okay, and if you want, I didn't do it up here, but if you want, sometimes people find it easier. They actually put like the elements over here too. Like they'll do something like this, which you can do that as well if that makes it easier for you to kind of keep everything organized. Okay. All right. So let's count. So remember, we've got reactant side on the left, product side on the right. So let's count how many of each thing we have. Manganese, we've got one here. Okay, so let's see. One. Oxygen, I've got two. Hydrogen, I've got one. Chlorine, I've got one. Okay, on the right side, manganese, I've got one. Oxygen, we have one. Remember, this two is just on that hydrogen. So oxygen, we just have one here. Hydrogen, got two. And chlorine, now if we look, we've got chlorine here and chlorine here, right? Okay, if they're in two different spots on the same side, then you would multiply to get those, but then you add this. So I've got two here, and I've got two over here, so I add those, the totals from each of those together. So I have 4 chlorine that I'm starting with. Okay? All right, let's do the balancing. So here, I'll highlight in front just so we can watch where we're putting our coefficients again. All right, so my manganese are, okay, so this is the helpful hint part. Balance elements in order of how many substances they are found in within the reaction from fewest to most. So if I look here, like manganese is in 2 spots in the whole reaction, right? Oxygen is in 2 spots. Hydrogen is in 2 spots, but chlorine is in 1, 2, 3 spots. So the helpful hint basically means I would do chlorine last because that's in the most number of spots. Okay, if they're tied for the same number of spots, then it doesn't necessarily matter, but that should help you a little bit. All right, so my manganese is already balanced, right? All right, let's go to, let's see, oxygens. Okay, so my oxygen, I've got 2 over here, and I've got 1 over here. So I need 2. So I'm going to put a 2 in front of this. 2 times 1, 2 oxygen. Okay, now don't forget, I also affected my hydrogen. 2 times 2 gives me 4 hydrogen. Okay, so now I look, didn't change my manganese. My oxygen is balanced. My hydrogen now, I've got 4 and 1. Okay, so I need 4 hydrogen on the left side. So I've only got 1 down here. So what number multiplied times 1? So it would be 4. 4 times 1. Okay, that gives me 4 hydrogen. Now, what does that do to my chlorine? Well, 4 times 1, so now I go to 4 chlorine. Okay, look what happened. Leaving chlorine to the end, it actually balanced before I even did anything with it. Now, it's not always going to happen, but here it did. Everything's balanced, and I didn't even have to like really do anything other than that. So we've got a balanced equation. All right. That is the notes. I'm gonna, this is your homework, the balancing equation sheet. Okay. If you print it off, then you might, it depends. Some people can write small enough to kind of get it in there. If you print this off, you do not have to rewrite the equation. You can just do the balancing in front of them. And you can use this to do your t-charts if you want, if you can fit them. Sometimes people just like more space. Like I'm a person who likes more space on mine. So I would probably do this on a separate sheet of paper. Okay. So I'm going to I'm going to pick a couple here. Okay. So I'm going to do number 5 here. Okay, so I'm just going to transfer it to this. So I've got Ag NO3 plus, and I'm leaving a little space in front so I can put my coefficients if I need them there to balance. MgCl2 yields AgCl plus Mg NO3 All right. So I'm gonna make my T-chart. Okay, now this is a little more complicated. So there's actually 2 ways you can do this one. So the first way, and sort of kind of your baseline, would be to I'm just going to put each of my elements, break everything up into elements. So Ag, N for nitrogen, oxygen, magnesium, and chlorine. Okay. All right. So I'm going to do my. Okay, so let's count, see how many of each we have. So silver over here, we have 1. Nitrogen, we have 1. Oxygen, we have 3. Magnesium, we have 1. Chlorine, we have 2. Okay, on the right side, I'm just going to get rid of this for now. Okay. On the right side, and this is number 5. Okay. On the right side, I have 1 silver. I have, okay, now, see this? On this, to figure out the nitrogen, what we're going to do is we're going to multiply our number out here, the subscript, times the subscripts we have inside of here, because the 2 goes to everything in here. So it's 2 times 1 for the nitrogen and 2 times 3 for the oxygen. So the nitrogen, 2 times 1 is 2 nitrogen. Okay, oxygen, 2 times the 3 gives us 6 oxygen. Okay. Right. Magnesium, now the magnesium is not affected. The 2 only affects everything inside the parentheses. Okay, magnesium is just 1. And then chlorine, 1. All right, let's do the balancing. So it doesn't matter which one I do first here, because they're all only in 2 spots in the whole thing. Okay, however, because the NO3 is together, I'm going to try the oxygen stuff. I might try to leave that till the end. We'll see what happens. Okay. So because chlorine isn't in with that, I might actually skip down and balance chlorine. Like the silver's balanced. I might skip the N and the O. My magnesiums are balanced. I'm going to go to my chlorine actually first. That might make my life easier. Okay, now if you do it just in the order you wrote them, that's fine. It'll still work. But all right, so I've got 2 chlorine on the left. I need 2 on the right. It's got a 1 down here, so I need to put a 2. Remember, once you start balancing, you're only changing coefficients. You never change the subscripts for the balancing. So I put a 2 in front of this. Okay, that gives me now 2 chlorine over here, but it also changes my silver, right? My silver goes to 2. Excuse me. Okay, now, so my chlorine's balanced, my magnesium's balanced. My silver now is not balanced, though, so I'm going to go and balance my silver. Excuse me. So I'm going to put a 2 in front of my silver over here. Okay, now remember that affects the whole thing. So that now gives me 2 silver. Okay, now it also gives me 2 times 1 for the nitrogen. It's 2 nitrogen. and it gives me 2 times 3 for the oxygen, or 6 oxygen. Okay, now let's check our numbers. 2, 2, 6, 1, 2. It's balanced. Okay, so we're balanced with that. Now, let me tell you something else here. If we went and we needed to, if we put a number in front, like say, excuse me, say I put a number in front of this, the MgNO3. Okay, let me use a different color here just to kind of differentiate. But let's say I went and I put a 2 in front of this. Okay, if I put a 2 here, it would be 2 magnesium, and then it would be 2 times 1, or 4 nitrogen. So like if I did that, my magnesiums would be 2, my nitrogen would be 4, 2 times 2 times 1, and my oxygens would be 2 times 2 is 4, 4 times 3 would be 12. Okay? All right, so that's not actually part of this balancing, but I wanted to kind of go over that. All right, let's see. So there is one other that I wanted to go over, and that is number 8. Okay, so number 8 on the sheet, C3H8 plus O2 yields CO2 plus H2O. All right, I'm actually going to pause and come back here. Okay, changed my mind after I just looked at something. I don't want to do 8 with you. I actually want to do number 9. 9 is a little more difficult. So we are going to do that one instead. All right, number 9. 9 is C8H18 plus O2 and it was still wet apparently. Okay, and yields CO2 plus H2O. Okay, so number 9. Same thing, I'm going to T-chart it. And I'm going to split up carbon, hydrogen, and oxygen. Okay. Here we go. Carbon on the left side. We got 8. Hydrogen, we have 18. And oxygen, we have 2. On the right side, carbon, we have 1. Hydrogen, we have 2. And oxygen, we have 3. Okay. So we go and carbon All right, so on this, I'm going to do oxygen last because oxygen is in 3 places. Everything else is in 2. Okay, so I'm going to do carbon. I've got 8. I've got 1. So I'm going to put an 8 in front of this. So I do 8 times 1, right? So I get 8 carbon. Now, that's going to kick my oxygen. So my oxygen, 8 times 2, is going to be 16 here, right? 8 times 2 is 16 oxygen. And then over here, I've got 1 oxygen, right? So we add those. 16 plus 1 means we now have 17 oxygen. Okay. All right. Let's look at our hydrogen. Our hydrogen, I've got 18 over here, and I've got 2 over here. So to get 18, I need to put a 9 in front of this. Okay, so 9 times 2 gives me 18 hydrogen. Okay, 9 times 1 now gives me 9 oxygen in this part. And I've still got 8 times 2 here, 16. So 16 plus 9 now moves my oxygens to 25. All right, now I specifically showed you this one because there's a little trick that you can do because my carbons are balanced, my hydrogens are balanced, my oxygens are not. I need 25 oxygens over here. But I can't do that because I've got to multiply whatever coefficient I put in front of oxygen times 2. So if I was to put a number here that would give me that, it would be half of 25. So this would be 12.5. Okay. But we can't do that. We can't put a coefficient. The coefficients must be whole numbers. Okay. You can't put fractions or decimals as coefficients. Okay. Not in balancing. So, but here's a little trick. Instead of like having to work your way back through the whole thing, oxygen is the only one that's not balanced, correct? So if we were able to put 12.5 here, that would balance everything because we would have 25 oxygen, 18 hydrogen, 8 carbon. Okay, but we can't put that. So it's 0.5, right? So the trick is if you double everything, if you double all your coefficients, okay, so we're going to, this is a 1, so that'll be 2. Okay, the 12.5 times 2 becomes a 25. The 8 sorry. The 8 becomes a 16. And the 9 becomes an 18. Double everything. Okay, now, you don't necessarily have to go through and check the numbers, but I would at first just to make sure. 2 times 8 now is giving me 16 carbon, right? Okay, let's check the carbons over here. Carbon 1 times 16 is now giving me 16 carbons. Okay, hydrogens, 2 times 18 is giving me, what is that, 36, I think? Yep. Over here, hydrogens, 2 times 18, 36. Okay, now my oxygens over here, 25 times 2. And we are getting 50 oxygens. Okay, over here, my oxygens, I've got 16 times 2 Okay, so that's giving me, what is that, 32 now? And 18 times 1, 18, for a total of 50. So the equation is balanced. 2C8H18 plus 25O2 yields 16CO2 plus 18H2O. Okay, so it's a little trick you can do. If the last thing you need to balance in order to balance has to be like half of like a 0.5, like not a whole number, as long as it doesn't affect anything else, you can go back through and double everything, and your balancing will come out correct. Right? Okay, hopefully that helps you guys. If you have any questions, make sure to message me, text me, or message me or whatever. And we will do the other part of the notes, the writing the equation part, tomorrow. Talk to you guys later.